Let w1, w2, w3 with 3 distinct subspace of R10. It is important distinct such that each wi has dimension 9. Let w define intersection of all these w1, w2 and w3. Then we can conclude that w may not be subspace of R10, dimension of w less than 8, less than equal to 8, dimension of w greater than equal to 7, and dimension of w less than equal to 3. We check each option one by one as w1, w2, w3. These three are distinct subspace of R10. Dimension of this over R is 10. If it is Q, then its dimension again 10. Now we know the result, or as a theorem, arbitrary intersection of subspaces of subspaces is again a subspace. So this intersection of these is again subspace. What option A says, not be a subspace, so option A discard here. Now in option B, C, D, these options about dimension of W and have either less than equal to or greater than equal to. It means we have to find lower bound or upper bound for dimension of W. As W is defined intersection of W1, W2 and W3, and we know the result only to, or remember, intersection of two subspaces, which is dimension of intersection W1 W2 is equal to dimension of W1 plus dimension of W2 minus dimension of their direct sum W1 plus W2. But this is equality, but we have to find inequality relation. So this should be changed by dimension of V, because if we put dimension of V here in place of this, then it is strictly dimension of W1 intersection W2 is strictly greater than or equal to this one. So we will use this concept here. So let intersection of W1 W2 as a W prime, then W will be W equal to W prime intersection W3, and we apply this result here. W equal to W prime intersection W3, where W prime is equal to W1 intersection W2. So dimension of W1 intersection W2 is less than equal to mean value, because this is intersection. It means intersection contains only common linearly independent vectors, because its basis contains only common linearly independent vectors or elements, so its dimension must less than equal to mean value of dimension of W1 or dimension of W2, and it is greater than equal to max value because dimension never be less than 0 or negative. So 0 comma dimension of W1 plus dimension of W2 minus dimension of V, as I discussed earlier. Here dimension of W1, because each subspace has dimension 9, so W1 dimension 9 plus 9 minus dimension of V, which is 10. So max value will be this. This is equal to 9918 minus 10, 8. Less than dimension of intersection of W1 intersection W2, less than dimension of W1 is 9, dimension of W2 is 9, so its mean value is also 9. We got an equality for dimension of W1 and W2. It means these are bounds 8 and 9. So possible dimension of W1 intersection W2 are either 8 or 9. If dimension is 9, if dimension of this intersection is 9, then its bases contain 9 linearly independent. Its bases contain 9 linearly independent, or W1 contain 9 linearly independent as well as W2. Then they cannot generate by different elements. So it means W1 and W2 are not distinct. Means hypothesis avoid this. So it is necessary dimension of intersection must be 8. Otherwise, if dimension is 9, then 9 linearly independent vectors in W1 and 9 linearly independent vectors in W2, and they are in common, so they cannot be different. So dimension of intersection is 8. Now W is W prime intersection W3. Now apply same inequality as I discussed. Dimension of W1 plus dimension of W2 minus dimension of V with 0, its max value should be less than equal to dimension of intersection W1 intersection W3, and which is less than dimension of mean value of dimension W prime comma dimension of W3. Now dimension of the W3 is 9 and dimension of W prime is 8. So mean value is 8. It means dimension of W prime intersection W3 less than and equal to 8, and this one is dimension of W prime is 8 plus dimension of W3, which is 9 minus 10 comma 0. Its max value will be this one. 8 9 17, 17 minus 10 7. So max value is 7. So this is dimension of W1 W prime intersection W3 have this inequality. It means 7 less than equal to dimension of W less than 8, and W is intersection of W1, intersection of W2, intersection of W3. Now come to the option. Dimension of W is greater than 7. This is true as discussed. And dimension of W is less than 8. It is also true. Now dimension of W is less than 3. Its dimension of W cannot be less than 3. So option D discard and A already discard. So correct options are B and C.